Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Okay, this is exercise 11.1, question number 1. This is 11th chapter theorem exercise, question number 1. It states that in a circle, two equal diameters AB and CD, they intersect each other, and we have to prove that AD is equal to BC. So we have taken a circle with center O, and there are two equal diameters as it is given to us, AB and CD, and they are intersecting each other at this point O. We have written this information in given step, and whatever we have to prove, that we have mentioned over here to prove that measure AD is equal to measure BC. Where is AD and BC? Here we have joined A to D and B to C in the step of construction, and we have mentioned it. Now, by collecting and organizing all that data, we are going towards the proof, which is the main part of this solution. And we divide it into two portions, as we know that statements and reasons. Here we are going to mention the correspondence between two triangles. Here, after doing this construction, we have got two triangles, and we are going to develop a correspondence between the two triangles OAD and OBC. And in these two triangles, now if we notice, this OA length is equal to this OB length, and what is the reason of their equality, as they are the radii of the same circle and they are equal. Similarly, here we can see OD is equal to OC. Again, they are the radii of the same circle, and these are the corresponding sides of these two triangles. And the third point, we can see that AOD angle, which is this angle, is also equal to BOC angle, which is this angle. And the reason for their equality is they are the vertical angles because they are created by the intersection of AB and CD, right? So we have completed the three formalities of side angle side postulate, and we can mention this triangle EOD is congruent to triangle OBC because of the side angle side postulate, and the corresponding sides of the congruent triangles are equal. So we can say that AD is equal to BC. Measure AD is equal to measure BC. So in a very simple way, we have completed it. Okay, this is question number 2 from exercise 11.2, and the statement is that in a circle, prove that arcs between two parallel and equal chords are equal. So we have taken a circle. We have taken this circle. Let me choose this spotlight. Okay, AB and CD are two equal and parallel chords in a circle with center M. Here we have, we can see that this AB and CD, here AB and CD are two equal. There are two equal chords and parallel chords in a circle with center M. Here is the point M. So we have to prove that this arc AC, this arc AC, and this arc BD, they are equal. So we have taken the step of construction. We have joined A to not only to C but also to D, and we have also joined B to C and D both. Now look at the step of proof. Now angle 1 and angle 8, they are the alternate angles because they are on the opposite side of the transversal AD, and they are between the parallel lines AD and BC. So angle 1 and angle 8, they are the alternate angles. You can see from the figure. Also, by the same reason, you can see that angle 2 and angle 7, they are also alternate angles. Now we can see that angle 1 and angle 7, now look at the chord BD. Here we have chord BD, right? And in this chord, we can see that this angle 1 and this angle 7, They are in the same segment. So angle 1 and 7 are equal because angles in same segment are always equal. And now we can see that angle 8 as it is equal to angle 1, and angle 1 we have proved that it is equal to angle 7. So it means angle 7 and 8 are equal. Now come to the triangle CMD. Here we have CMD triangle. In this triangle, we have proved that angle 7 and angle 8 are equal. So their opposite sides will also be equal. And their opposite sides are DM and CM. So they are equal because they are the opposite sides of 7 and 8. In the very same manner, here in this diagram, we can all prove the whole sequence of logic that we have tried in triangle CMD. We can apply in AMB, and we can prove that AM is equal to BM. As we have proved that DM is equal to CM, we can prove that AM is equal to BM. We have got these results as number 1 and number 2 over here. Now we're going to add the left hand sides and right hand sides. AM and BM, when they're added, will give us BM plus CM. We are adding 1 and 2. And from the figure, we can see that AM plus DM is equal to AD and BM plus CM is equal to BC. Here we have mentioned this sum. Now we're taking the correspondence of triangle ABD. Here in the figure, you can see ABD and ABC. The correspondence of these two triangles means that we intend to prove them congruent in the next lines. So let's see. AB is a common side in both of these triangles. We have mentioned angle 1 and 2. We have already proved here that angle 7 and 8 are equal. So 7 and 8 are equal, so it means 1 and 2 are also equal. We have proved it in our first and second line. So angle 1 and 2 are equal. We have already proved it. And now we have proved AD is equal to BC, and we are mentioning it over here. We have proved it. So these are the 3 results that we have gained. And so the triangle ABD and triangle ABC, they are congruent, side angle side postulate. So their corresponding sides are congruent, and their corresponding sides are AC and BD. One of the corresponding sides. And if 2 chords are equal, then their corresponding arcs will also be equal. So arc AC will be equal to arc BD. So in this way, we have proved that these arcs are equal. Now move to the next question. And the statement of the question number 3, 11.1 exercise is that give a geometric proof that a pair of bisecting chords are the diameter of a circle. Here we have taken a circle and we have taken chord AB and CD, which are bisecting each other at some point Q. So we are assuming that Q is their midpoint, and because they are bisecting, so it is the midpoint, and we have to prove that these 2 chords AB and CD are the diameters of the circle. So if somehow we become able to prove that O is actually the center of the circle, O is actually the center of the circle, it means that CD, as it is passing through the center of the circle, so it is a diameter. Also AB, which is passing through the center of the circle, is a diameter. But right now, Q is just a midpoint of AB and CD. So we will ourselves assume that there is some center O of this circle, and we will draw a perpendicular OM on CD. In order to prove this whole statement, we have to take some other point. Let's see if we take some other point O as center, what happens? It means now we have taken OM is perpendicular to CD. Now it means that if this is the OM is the perpendicular and it is coming from point O. So according to theorem 9.3, any perpendicular from the center of the circle on a chord bisects it. So as OM is linked to the center of the circle and it is perpendicular to CD, so it means M is the midpoint. So it means CM and DM are equal, and according to theorem 9.3, M is the midpoint of this chord CD. But also we have assumed that the midpoint of CD is Q. Q is also the midpoint. Now M is also the midpoint according to our assumption. So it means that Q and M, they are coinciding with each other. They are not different points. They are the same points. So M is not perpendicular to CD. and M is the same point, which is like O, because according to the diagram of our theorem 9.3, you can see that here is the center, and if there is some perpendicular on some chord, then this chord is this perpendicular is bisecting the chord. And if you fit this situation to this diagram, it means that M, O, Q, they all are the same points, and the center of the circle, it must be M or O or Q. It's the same point. These are the same points. If we assume O to be some other point, we cannot prove it. So they are the same points. So it means that Q is actually the midpoint of CD, but also the center of the circle. So and the chord CD, as it is passing through the center of the circle, so it is the diameter by definition. Now move to question number 4. Now statement of question number 4 is that if C is the midpoint of an arc ACB in a circle with center O, show that the line segment OC bisects the chord AB. According to this data, we have drawn it here. This is the arc ACB, and here is the midpoint C of this arc, and we have to show this the line segment OC. It is bisecting this chord AB, right? So we have mentioned the data over here. We have organized it that a circle with center O, ACB is the arc. We have to prove that Meyer AB is equal to Meyer AM is equal to Meyer BM, and here we can see that the line segment OC is bisecting the chord. This is OC and it is bisecting the chord. And here is the point M. It means that we have to prove that this distance AM is equal to this distance BM. We have joined O to A and B so as to create a situation of the triangles. Now come to the proof. As we are given that arc AC is equal to arc BC. This was the midpoint, so arc AC is equal to arc BC. If the arcs are congruent, then their corresponding chords are also congruent. This is the statement of theorem 11.1, and so corresponding chord AC and BC are equal. We have mentioned them equal over here. Now, if the chords are equal, then they subtend equal angles on the center. This chord AB, and you can draw a chord over here, AB, AC, and BC, and these chords are subtending equal angles at the center. This is the statement of theorem 11.3. So angle 1 and 2, they are equal. So in triangle OME and OMB correspondence, OM is common to OM, angle 1 is congruent to angle 2. We have proved it over here. And OA and OB, they are the radii of the circle. So by combining these three, we can say that OMA is congruent to OMB, side angle side postulate. And if triangles are congruent, then their corresponding sides are congruent. So AM is congruent to BM, corresponding sides of the congruent triangle. So in this way, we have proved this result also. I hope everything is clear. Allah Hafiz.